Lesson 7.5. We're going to do some examples to get you started on your assignment. So it says, does your solution for the equation in problem 13 match the solution found using a graphing calculator as shown? Explain. All right, so we need to solve this equation. So we've got 2 times the cube root of x minus 4 minus 6 equals 0. So the first thing we're going to do is add 6 to both sides. So we've got 2 times the cube root of x minus 4 equals 6. Then we have multiplication, so we're going to divide to get rid of that 2. And then we have to get rid of the cube root. So to get rid of the cube root, we have to cube both sides. So cube root cancels cube power and leaves x minus 4. 3 to the third power is 27. Add 4. X equals 31. All right, now let's see what the graphing calculator shows. All right, so if you go to y equals, this is where you go if you want to graph things. And we're going to graph it when the two sides are isolated. So if I come down here, I can see the two sides are isolated when the cube root of x minus 4 is on one side and 3 is on the other side. That's before we take the third power on both sides. So we're going to say y equals 3 is on one side. And then we can do cube root. Number 4 is cube root of x minus 4. And then I'm going to arrow out to get out from under the radical. And then I'm going to hit graph. All right, my window is already expanded. If your window is not expanded, I have x equals 31. All right, so when I go to my window, I want to make my positive x's a little bit further than 31. So I made it 35. All right, so when I hit graph, I can see that it is going to intersect out here somewhere. But because this is so small, it's kind of hard to see. So I can do second trace. Number 5 is intersect. So I'm going to hit number 5 because I want to find the intersection point. I'm going to scroll out through here a little bit further. I know my answer should be 31. So I can see here my x is 20 at this point. So I'm going to click on that to be on the left side. Second curve, I need it to be just past 31. So that says x is 32. Then I hit intersection. Then I hit enter again and it gives me my intersection. So this says that my intersection is at x equals 31, y equals 3. So the graphing calculator does show that these two lines intersect at x equals 31. All right, so that means that is a true solution. If we want to check it algebraically, we would plug the number back in and we would check it. So we've got 2 times the cube root of 31 minus 4 minus 6, and we want to know, does that equal 0? All right, so 2 times the cube root of 31 minus 4 is 27. And the cube root of 27 is 3. And 2 times 3 is 6. 6 minus 6 is 0. So 0 equals 0. So algebraically it checks out, and it checked out using the graphing calculator. All right, let's look at a couple more examples. So we want to solve and then check to make sure our solutions are solutions. So we're going to add 6 to both sides. All right, and then I've got a square root. So to undo a square root, I'm going to square both sides. So I'm going to be left with negative x plus 1 equals 6 squared, 36, minus 1. Negative x equals 35. Divide by negative 1. X equals negative 35. Alright, now I need to plug that back in to see if it works. Alright, so I'm going to say, let's change the color here. I'm going to say negative 35. X is negative 35, and there's already a negative there, so that's why there's two negatives here. Plus 1 minus 6, does that equal 0? Alright, so that's 35 plus 1 is 36. Square root of 36 is 6. 6 minus 6 is 0. So that checks out. So that is a true solution. Alright, on to question, or whatever question this is, 2 or 3. Alright, so I'm going to add 1 to both sides. I'm going to have the cube root of x plus 4. That's going to equal 1. I'm going to cube both sides to get rid of the cube root. So I'm going to have x plus 4. 1 cubed is 1. 1 to any power is 1. And then I'm going to subtract 4. X equals negative 3. All right, with a cube root, the domain is all real numbers, so this one should work because it can be positive or negative when it's an odd root. But let's check it anyways because it's always a good idea to check your answers. So we're going to have cube root of negative 3 plus 4 minus 1. Does that equal 0? So that's a cube root. Negative 3 plus 4 is 1. 1 minus 1 is 0. So yes, this one works as well. All right, let's look at a couple with rational exponents. All right, so these work pretty much the same way. First thing we need to do is isolate the exponent. So we're going to have 2x minus 5 to the 1/2 power. That equals 7. If I square both sides, squared 1/2 times 2 is 1, so this will cancel just like it does with the square root. So we've got 2x minus 5 equals 7 squared. And I'm going to add 5. I'm going to have 2x equals 49 plus 5 is 54. Divide by 2. X is 27. Alright, so plug it back in and see if it works. So let's plug it in real quickly. 27 times 2 is 54. 54 minus 5 is 49. 49 to the 1/2 power, same thing as square root of 49, so a 7. 7 minus 7 is 0, so this works. Alright, next question, we're going to add 24 first. First we have to isolate the exponent, just like we did with the radicals. Then I have to divide by 6 because that's the opposite of multiplication. (24) divided by 6 is 4. And then this is to the 1/3 power, which is the same thing as a cube root. So I'm going to cube both sides. So 1/3 of 3 is 1, so that just leaves x plus 4. 4 cubed is 64 minus 4. X equals 60. Alright, plug it back in and check it. Alright, 60 plus 4 is 64. 64 to the 1/3 power is 4. 4 times 6 is 24. 24 minus 24 is 0. So again, we are mentally checking this one, and it works out. Alright, that's a few examples. If you have any questions, please let me know.